Today we're going to talk about power plants and the energy conversions that take place within them. We're going to start off by talking about a nuclear power plant. There we have uranium atoms that are split. This would be considered a nuclear process. So the splitting atom, the starting energy that we have is nuclear energy. From there, though, that energy that is released is used to have water turn to steam. So there's an increase in temperature and an increase in thermal energy. So that thermal energy then causes water to become steam. So because that water is heated, again, we're going to have thermal energy, and it is going to then cause a turbine to move. That turbine then, because of its movement, it will have mechanical energy. So the mechanical energy of the turbine moving then will build up an electrical charge. Anytime that you have a turbine moving, we can get electricity that comes from that. So our overall energy conversion starts with nuclear energy and then has a conversion to electrical energy, and that electricity then can come out to our homes and the businesses around us. Now we're going to take a look at a fossil fuel plant. It is very similar in the energy conversions that take place, except for the fact that in the very beginning, we have coal that is being burned. Coal is a fossil fuel, and when we burn that, we're releasing that energy. So it has chemical potential energy in that coal that is released then when it is burned. So because it's being burned, it will give off thermal energy. That thermal energy, again, is going to heat water that will become steam. It will move and then end up moving a turbine. That mechanical energy of moving a turbine then can produce electricity or electrical energy. Our overall energy conversion this time is chemical energy ending up with electrical. Now notice, just like our nuclear power plant, everything is the same there except for that starting energy. Here we're starting with chemical energy rather than nuclear energy. The last power plant that we're going to look at is the hydroelectric plant. This is where water is held back behind a dam, but we eventually get electricity from that. So we have water that's held behind the dam. It's up high, and therefore it has gravitational potential energy, but it is allowed to move and move down, so that movement would be considered mechanical energy. The mechanical energy of the moving water goes right to more mechanical energy, but this time it's causing the turbine to move. And just like we've said in the other power plants, anytime that you have a moving turbine, which would be mechanical energy, it can create electrical energy. Here, our overall energy conversion goes from GPE, gravitational potential energy, to electrical energy. So this one's a little bit different. There isn't anything burning. We don't have water that's being heated up, but we do have water moving. So each of these power plants have things that are in common. We end up with electrical energy that we can use, that can be sent out to our homes, but also the way that they start would be different between them. So that leads into the questions that you have to answer on this worksheet, where you are able to compare and contrast these different power plants.